Acrylonitrile, Wikipedia article audio. Acrylonitrile is an organic compound with the formula CH2CHCN. It is a colorless volatile liquid, although commercial samples can be yellow due to impurities. In terms of its molecular structure, it consists of a vinyl group linked to a nitrile. It is an important monomer for the manufacture of useful plastics such as polyacrylonitrile. It is reactive and toxic at low doses. Acrylonitrile was first synthesized by the French chemist Charles Moreau in 1893. Acrylonitrile is not naturally formed in the atmosphere of Earth. However, it can occur at levels up to 0.11 ppm at industrial sites. It persists in the air for up to a week. It decomposes by reacting with oxygen and hydroxyl radical to form formyl cyanide and formaldehyde. Acrylonitrile is harmful to aquatic life. Occurrence. Production. Acrylonitrile has been detected in the atmosphere of Titan, a moon of Saturn. Computer simulations suggest that on Titan conditions exist such that the compound could form structures similar to cell membranes and vesicles on Earth. Acrylonitrile is produced by catalytic amoxidation of propylene, also known as the Sohio process. In 2002, world production capacity was estimated at 5 million tons per year. Acetonitrile and hydrogen cyanide are significant byproducts that are recovered for sale. In fact, the 2008-2009 acetonitrile shortage was caused by a decrease in demand for acrylonitrile. In the Sohio process, propylene, ammonia, and air are passed through a fluidized bed reactor containing the catalyst at 405-10 degrees C and 5200 kPa. The reactants pass through the reactor only once, before being quenched in aqueous sulfuric acid. Excess propylene, carbon monoxide, carbon dioxide, and dinitrogen that do not dissolve are vented directly to the atmosphere, or are incinerated. The aqueous solution consists of acrylonitrile, acetonitrile, hydrocyanic acid, and ammonium sulfate. A recovery column removes bulk water, and acrylonitrile and acetonitrile are separated by distillation. Historically, one of the first successful catalysts was bismuth phosphomolybdate supported on silica as a heterogeneous catalyst. Further improvements have since been made. Various green chemistry routes are being developed for the synthesis of acrylonitrile from renewable feedstocks, such as lignocellulosic biomass, glycerol, or glutamic acid. The lignocellulosic route involves fermentation of the biomass to propionic acid and 3-hydroxypropionic acid, which are then converted to acrylonitrile by dehydration and amoxidation. The glycerol route begins with pyrolysis to acrolein, which undergoes amoxidation to give acrylonitrile. The glutamic route employs oxidative decarboxylation to 3-cyanopropanoic, followed by a decarbonylation elimination to acrylonitrile. Of these, the glycerol route is broadly considered to be the most viable, although current methods are still unable to compete with the Sohio process in terms of cost. Acrylonitrile is used principally as a monomer to prepare polyacrylonitrile, a homopolymer, or several important copolymers, such as styrene acrylonitrile, acrylonitrile butadiene styrene, acrylonitrile styrene acrylate, and other synthetic rubbers such as acrylonitrile butadiene. Dimerization of acrylonitrile affords adiponitrile, used in the synthesis of certain polyamides. Small amounts are also used as a fumigant. Acrylonitrile and derivatives, such as 2-chloroacrylonitrile, are dienophiles in Diels-Alder reactions. Acrylonitrile is also a precursor in the industrial manufacture of acrylamide and acrylic acid. Emerging industrial routes. Acrylonitrile is highly flammable and toxic at low doses. It undergoes explosive polymerization. The burning material releases fumes of hydrogen cyanide and oxides of nitrogen. It is classified as a Class 2B carcinogen by the International Agency for Research on Cancer, and workers exposed to high levels of airborne acrylonitrile are diagnosed more frequently with lung cancer than the rest of the population. It evaporates quickly at room temperature to reach dangerous concentrations. Skin irritation, respiratory irritation, and eye irritation are the immediate effects of this exposure. Acrylonitrile increases cancer in high-dose tests in male and female rats and mice. Uses. Pathways of exposure for humans include emissions, auto exhaust, and cigarette smoke that can expose the human subject directly if they inhale or smoke. Routes of exposure include inhalation, oral, and to a certain extent dermal uptake. Repeated exposure causes skin sensitization and may cause central nervous system and liver damage. There are two main excretion processes of acrylonitrile. The primary method is excretion in urine when acrylonitrile is metabolized by being directly conjugated to glutathione. The other method is when acrylonitrile is metabolized with 2-cyanoethylene oxide to produce cyanide end products that ultimately forms thiocyanate, which is excreted via urine, or carbon dioxide and eliminated through the lungs. Metabolites can be detected in the blood and urine. Acrylonitrile induces apoptosis in human umbilical cord mesenchymal stem cells. Health effects.